Assalamualaikum and hello everyone. Thank you for watching the video. My name is Muhammad Fakur Naim Jafar and my metric number is 198346. So today I will be presenting to you about the metal oxide silicon field effect transistor or known as MOSFET. First we go to the introduction to MOSFET. A MOSFET transistor is a semiconductor device that is widely used for switching purpose and for amplification of electronic signals in electronic devices. A MOSFET is a four-terminal device having source, gate, drain, and body terminal. The body of the MOSFET is in connection with the source terminal, thus forming a three-terminal device such as a field effect transistor (FET). Generally, MOSFET is considered as a transistor and employed in both analog and digital circuits. Next, we go to the type of MOSFET. The MOSFET is classified into two types based on their type of operation. First one is the enhancement mode MOSFET, and the second one is the depletion mode MOSFET. These MOSFET are further classified based on the material used for construction, as N channel and P channel. So, in general, there are four types of MOSFET. First one is the N channel depletion mode MOSFET. Second one is the P channel depletion mode MOSFET. Third one is the N channel enhancement mode MOSFET. And the last one is the P channel enhancement mode MOSFET. Moving on, we go to the how does MOSFET work. So the main principle of a MOSFET is to be able to control the voltage and the current flow between the source and the drain terminal. In general, the MOSFET works as a switch where the MOSFETs control the voltage and the current flow between the source and the drain. The working of the MOSFET depends on the MOS capacitor, which is the semiconductor surface below the oxide layer between the source and the drain terminal. It can be inverted from P-type to N-type simply by applying positive or negative gate voltage respectively. So here we have the diagram of the working principle of a MOSFET. So when we apply positive gate voltage, the hole present under the oxide layer with a repulsive force and the hole are pushed downward with the substrate. The depletion region populated by the bound negative charge which are associated with the acceptor atom. The electron reach the channel is formed. The positive voltage also attracts the electrons from the N plus source and the drain region into the channel. Now, if a voltage is applied between the drain and the source, the current flow freely between the source and the drain, and the gate voltage control the electrons in the channel. But if we apply the negative voltage, a whole channel will be formed under the oxide layer. Next, we go to the MOSFET characteristic. We have a table of MOSFET and their region of operation. From the table, we know that the MOSFET is seen to exhibit three operating regions. The first region is the cut-off region. In this region, MOSFET will be off as there will be no current flow through it. MOSFET behave like an open switch and used when they are required to function as electronic switches. The second region is the ohmic or linear region. The current IDS increases with an increase in the value of VDS. When the MOSFET are made to operate in this region, they can be used as amplifiers. The last one, we have the saturation region. In this region, MOSFET have their IDS constant in spite of an increase in VDS and occur once VDS exceeds the value of pinch of voltage VP. The device will act like a closed switch through which a saturated value of IDS flows. Moving on, we go to the application of MOSFET. So MOSFET is used for switching and amplifying electronic signals in the electronic devices. It can be used as an inverter and it can be used in a digital circuit. MOSFET can be used as a high frequency amplifier, can be used as a passive element in resistor, capacitor and inductor, can be used in a brushless DC motor drive, can be used in electronic DC relay, and last but not least, it can be used in the switch mode power supply as MPS. Before we go to the conclusion, here is some comparison of BJT, FET, and MOSFET. The first one is BJT or bipolar junction transistor. there are three terminals that are identified as emitter, base, and collector. For FET or field effect transistor, there are also three terminals, but the terminals are source, drain, and gate. The difference between MOSFET and BJT and FET is MOSFET is a special type of FET which gate is insulated from the main current carrying channel. It also be called as IGFET or insulated gate field effect transistor. In conclusion, the MOSFET has three terminals which are source, gate, and drain. The most common use of a MOSFET is as a switch, as MOSFET control the voltage and the current flow. There are two types of MOSFET, enhancement and depletion mode, and both modes have P and N channels, thus creating four different types of MOSFET. The characteristics of the MOSFET exhibit at three different regions, which are called as the cut-off region, ohmic or linear region, and saturation region. And lastly, the MOSFET is really different compared to BJT, but the working principle for the MOSFET is really similar to FET. Here is the references that I use in order to complete the individual assignment. Thank you for watching the video and thank you everyone. Bye bye.